So we're going to spend a lot of time in Chapter 2. This is going to be the bulk of what we're going to cover in regards to the descriptive branch of statistics. Displaying data, organizing data, analyzing and looking for trends and other notable features within data sets. One of the first things that we do to organize data very commonly is a frequency distribution. So we have a table that shows the classes of the data. The classes are just mostly arbitrary groups that we use to kind of cluster a bunch of the data sets. We have very formal ways of finding it, but how we get the classes can vary a little bit from data set to data set. There's a lot of things that go into consideration when you're determining the classes. So we set up a class like you see on the example, and our first class is values 1 through 5. And so that class includes any time we get a data value of a 1, a 2, a 3, a 4, or a 5. The frequency tells us how often a number appears in that class. It does not tell us what those specific numbers are. So our first class has a frequency of 5. That means that 5 numbers in our data set are between 1 and 5. They could all be 1s, they could all be 3s, they could all be 5s. I could have 2 3s and 3 4s. Any combination of values between 1 and 5, where I have 5 of them. Okay? In the second class, I have 8 numbers between 6 and 10. I don't know how many of each number, I just know that there's 8 of them in that group. How we get our classes, we have a lower boundary and an upper boundary called the class limits. Lower class limit is the smallest number that can be in that class. Upper class limit is the largest number that can be in that class. When we find the difference between lower class limits, that gives us the class width. And so if we look at our first 2 lower class limits, what is the difference between 1 and 6? What's the difference between 1 and 6? 5. So our class width is 5. And you'll see that that width is consistent from class to class. The difference between 11 and 6 is 5. 11 and 16 is 5. 16 and 21 is 5. So every lower class limit will have the same distance between it. The same is true for the upper class limits. 10 is 5 more than 5. 15 is 5 more than 10. All the way down. So that difference will be common within every single class between consecutive lower limits or consecutive upper limits. The range tells us the difference between the minimum value and the maximum value of the data set. We use the range to find our class width. So there's 4 steps in constructing a frequency distribution. We start by deciding on the number of classes we're going to have. How many groups are we going to break the numbers up into? The general rule of thumb is somewhere between 5 and 20. The exact number is going to depend on how big your data set is, how spread apart your data values are, and it's a little bit of arbitrary decision making. But the idea is if we have not enough or too many classes, it becomes really hard to identify any patterns or trends in the data. Once we've determined the number of classes, and for our situation, most of the time, you're going to be told how many classes to use. Once we know how many classes we're going to use, we need to find the class width. So we take the range, the difference between the minimum and the maximum, and divide it by the number of classes. We figure out how spread apart our data is, and then we break up that data into even groups. Usually we get a decimal when we do that, so we want to make sure that we're always rounding up to the next convenient number. Usually it's an integer value. Okay, so we'll usually round up to the next whole number. Once we know how wide our classes are going to be, then we can find our class limits starting with the minimum entry, what our lowest value is, and then we add the class width to find the next lower class limit. And then do it again to find the next lower class limit and the next one, over and over and over. And then we can find the upper class limits by looking at the next lower class limit. We don't want any gap between one upper class limit to the next lower class limit. So when we look at our first frequency distribution, if I have all of my lower class limits and I'm trying to find my upper class limits, I have to think, okay, well, this group starts at 1 and the next one starts at 6. So I don't want there to be a gap between when one class ends and the next one begins. So we have to have our first group go all the way up to 5, so then the next one starts at 6. And goes all the way up to 10, and the next one starts at 11. So we don't want to leave any gaps. So it's usually one less than the previous lower class limit. Once we've got all our class limits, then we just count up the data and see how many data values go in each group. Once we have that tallied, we can total to get our frequency. So we have a data set of cell phone screen times measured in minutes of 30 U.S. adults on a given day. So how many minutes they spent using their phone in a particular day. We want to make a frequency distribution that has 7 classes. So our first step is identifying the number of classes that was given to us as 7. Most of the time, I'm going to be giving you how many classes we want. Researchers have to make an arbitrary decision, and sometimes they try different class widths to see what's going to work best, which one highlights the trends in the data better. Second step is to find the class width. In order to do that, we have to have the range divided by the number of classes. My range is my minimum value subtracted from my maximum value. So we need to look at that data set and find those two numbers. What is the minimum value of my data set? The smallest number that's there.
155.
So we got 155, smallest number in that data set. What about the largest?
405.
405. So we have a minimum value of 155 and a maximum value of 405. So to find our range, we subtract the two. 405 minus 155, and then divide it by the number of classes, which they told us was 7. What's 405 minus 155?
250.
250. And then divide it by 7. 35. Yep. 35.7. So because we have a decimal, we want to round up to the next convenient number. 36. So we're going to use 36 as our class width. Step 3 is to get our class limits. So we start with our minimum. And that is our first.
And then you add 36.
So we add 36. And we add 36 over and over and over until we have all 7 classes that we need. So what is 155 plus 36? 191 plus 36 again. And again. Again. 191, 227, 263, 299, 335, and 371. So we just added 36 over and over and over, all the way down until we got all 7 lower class limits. Go back. 3, 6, and 7. Okay? There's all of our lower class limits. Now we need our upper class limits. So our first group starts at 155, and it needs to go all the way up to the second group. The second group starts at 191. So where does our first group need to end? One before. At 190. And we can keep doing that and say, okay, the third group starts at 227. The second group needs to end at where? 226. Also, just like we added 36 to get the lower class limits, we can do the same thing to get the upper class limits. Add 36, add 36, add 36. You're going to have to do that in order to get the last one, because we can check with the next lower class limit for each of these, and we get 262 and 298, 334, and 370. But then when we the last one, I don't have another lower class limit to check. So I take 370, add the class width, and we get 406 as our final upper class limit. Now that we have all of our class limits, we can count the values. And we can tally them up. So starting with 200, which group, which class is the number 200 going to fall into? The second one, 191 to 226. So we cross off 200, and we put a tally mark in the second group. 239, which group is that going to go in? The third one. 155. And the first one. 252. Third one again, so we have a second tally mark. Keep going. Tally them all up. How many do we end up with our first group? Second group? How many in the third group? Fourth group? Next group? Sixth group? And last group? Now, add these up. What do you get? 30. What is 30? Say again. 30 adults. The The sum of your frequencies should equal your sample size. So once you've done your frequency table, do a quick addition, make sure that number matches up. The sum of your frequencies must equal your sample size. So you can use that as a kind of checksum to make sure that you didn't miss something. If you did, well, then you go back and retally them up. So now we're going to look at a few other things that we can do with a frequency distribution. So same chart continued. All right, we see all of our 7 classes. We see our frequencies here. Next thing that we can do with a frequency distribution is find the midpoint of a class. The midpoint of a class is often used when we're doing estimations for different measurements that we want to find in relation to a data set. So if I wanted to find the mean or the median or the mode or the standard deviation or any type of those measures from a frequency distribution, I don't know what the individual data points are, but I have an estimate for those data points and how many I have. So the midpoint can be used as one of those estimations. The midpoint is the average of the lower class limit and the upper class limit. How do I find the average between two numbers? We add them up and divide by how many? In this case, it's 2, because we're averaging the lower class limit and the upper class limit. We take 155, add it to 190, divide by 2. What's our midpoint? 172.5. 172.5. So that is the number that is right in the middle of that first class. Do the same thing for the second class. We can do 191 plus 226 divided by 2. .5. What's the difference between those two numbers? Not 35. Yep. 36. What is 36? It's the class width. So the difference between subsequent midpoints is also the same as the class width. So just like we found subsequent lower class limits and subsequent upper class limits, by adding the class width, we can do the same thing with our midpoints. Once we find the first one, we can add the class width to find each remaining one. We can add 36. And I can do it again, and we get a midpoint of 244.5, and we can do it again, 280.5, and again, 316.5. Like getting all wonky on my line. Divided by 2.
Why are you dividing by 2?
Because we're finding the average of those two numbers. Finding the average of the lower and the upper.
So it's divided by 2 and then you add 36.
No. Or we could add,
that difference is 36.
Exactly. We find the first one. We have to find the average of the first one. We could calculate the average for each and every single one of these classes, and it will give us all the midpoints. Or we can just take the first one, add 36 to get the second, add 36 to get the next, plus 36, plus 36. Our next class is 352. 45. Can't read my numbers from here. 388.5. So those are our 7 midpoints for each of the classes. And again, the midpoints are often used when we need to do an estimation Midpoints are used when we are graphing our data. We'll see how those are used in some of our histograms later on. Next thing that we can do is our relative frequency. Gives a percentage of the data for that specific class. What percent of the data falls in that group? Relative frequency is just the frequency of the class divided by the sample size. What's the frequency of my first class? What's the frequency of the first class? 3. What's the sample size? 30. So, frequency divided by 30 gives us a decimal. We want to round to the nearest percent, so that means 2 decimal places. So our first class is 10%.
Wait, why are we dividing by 30 and not 36?
36 is the class width, 30 is our sample size. 30 adults.
Oh, okay.
So 10% of the adults use their phone between 155 minutes and 190 minutes on a given day. Okay. What is my frequency for my second group? 2. And my sample size? 30 still. So we do 2 divided by 30. And we get 0.07. 7% of adults use their phone between 191 and 226 minutes a day. We keep going through that. 5 divided by 30. And 6 divided by 30. And 7 divided by 30. 4 divided by 30. And 3 divided by 30 again. And we get 10%, 7%, 17%, 20%, 23%, 13%, and 10% again. Add up all of those decimals. What do we get? Not 30.
1.
We get 1. 0.1 plus 0.07 plus 0.17 plus 2 plus 2.3 or plus 0.23 plus 0.13 plus equals 1. The sum of the relative frequencies needs to equal 1 because they are percentages. If we add up all the percentages, we should get what percent? 100%. It should include everybody. So 1 is 100%. Relative frequency should add to 100%. So again, you can use that as a checksum, especially when you're not sure about your rounding. If you're not sure if you rounded a percent correctly, you can use that to see, does it all add up to 1? As long as you round it correctly, then it should add up to 1. Cumulative frequency, sum of the frequency for that class and all previous classes. So it gives a running total as we go through each class. So we start with our first one, and the total of the frequency so far is just 3. Just started. And then for the second class, again, we're creating a running total. So we take the first class, plus the second, and we get a cumulative frequency of 5. And then the third one, we add the third frequency to the previous total. So we take the previous one, add the next frequency, 10 plus 6, 16 plus 7, 23 plus 4, and 27 plus 3. And again, cumulative frequency of the last class is equal to the sample size, because we're getting a running total. Once we've run through all the classes, we should have the total. When we want to describe patterns in the data set, we're looking for a couple things numerically. What class is the largest frequency? What class is the smallest frequency? Is there a group of classes that contain most of the data? Is there a class that has an unusually high or low amount of data? Okay, looking for any type of those numerical trends for things that are in common or things that are out of the ordinary. So what are some trends that we see with this data? So in the middle, the frequency starts to go up till about where?
The last one. From there to...
Okay. So we see a big jump in our frequency between 227 and 334 minutes. We have a lot of data in that grouping. So if we look at just those three rows, oopsies, I'll let that part out. This row here, there we go, got it. Okay. One thing we do is we can look at the relative frequency. Relative frequency gives the percentage for each of those classes out of the whole. If we're looking at all three classes together, what is that total percentage? 0.6, which is what percent? 60%. If I add up those three frequencies, those three relative frequencies, we get 60%. So that's part of the trend. 60% of adults use the phone between 227 minutes and 334 minutes a day.
What did you add?
I added the three relative frequencies. 0.17, 70%, 20%, and 23%.
Oh,
and that gives us 60%. Okay? So we can see that we have a big jump in frequencies in the middle. Okay? We can also look at specifics. What is the group with the highest frequency? What is the group with the highest frequency?
the 299.
Yeah. So 299 to 334, that's our class that has the highest frequency. So that's a pattern in the data set. It could, depending on our information, it could be notable whether our highest frequency is at the back, or it's at the beginning, it's at the middle, it's at the end. That could show trends in the data. Which class has our lowest frequency? The second one, from 191 to 226, that is our lowest frequency. Okay? So there's a lot of different ways that we can look at the data. What's the lowest group? What's the highest frequency group? Do I have a chunk of data together that contains most of my information? All of those are different ways that we could interpret different patterns. Now, once we have our frequency distribution and we're looking at our different relative frequencies, cumulative frequencies, we have several different ways that we can graph and display this data in a non-numerical way, right? That allows us to visually see the patterns. Same patterns will arise, they might be a little bit easier to see with the different graphic displays. The first one is a histogram. It's a bar graph. Bar represents a class. So for every single class, we'll have a different bar. That's a horizontal axis. The x-axis lists each class. The vertical bar tells us the frequency of that class. The higher the frequency, the taller the bar. The lower the frequency, the shorter the bar. If we happen to have a class with 0 frequency, then there would be no bar there. Consecutive bars have to touch on a histogram because we're looking at groups of data. We're looking at a range of values. And when we look at our tables, we don't have a gap. from one to the next. So the bars have to be touching. If the bars have a gap, then that means there's a class that has no data values in it. So we need to make sure that we're very careful about that with our histograms. Now, how the graph can be shown, there's a couple different ways. Again, because we're looking at that at the transition from one class to the next, we don't want a gap. Instead of using class limits for the histogram, a lot of times they use class boundaries instead. Because the consecutive bars have to touch, we have to begin and end at class boundaries, which is half the distance between the classes. If one class ends at 190 and the next one ends at 191, we need to have the class boundary right in the middle of the two. Well, what number is right in the middle of 191 and 190? 190.5. So we have that class boundary of 190.5. And when you look at the bar graph here, we see how this bar ends and the next one begins at 190.5. Okay, so it sets that limit. And then the next class begins and ends at 226.5. And we see that one class ends at 226, and then at 227, 226.5 is right in the middle. So often we're adding 0.5 to the upper class limit to get the upper class boundary. And then that makes the lower class boundary for the next one. Notice how these are the same. Okay? The upper class boundary of one is the lower class boundary of the next. To get the lower class boundary of the first, we want to go 0.5 in the other direction. So we subtract 0.5 from 155 to get the lower class boundary of 154.5. And so we get our graph, and we can set up each of these tick marks down here as each of those class boundaries. And then we look at the frequency for each of those classes. The first class had a frequency of 3, so the bar goes up to 3. The next class had a frequency of 2, so the bar goes up to 2. The next class had a jump of 5, and so on. Same trends are evident. We see that the second class is the lowest frequency. We see that the fifth class is the highest frequency. We see that most of our data is clustered there in the middle. So the same trends that we picked out earlier, we see visually on the graph. The other way to represent with the same information, instead of using class boundaries that give the starting and stopping points of each class, is we can use the class midpoints. So those midpoints that we found earlier can be used to mark each class. And notice how the tick mark is in the middle of the bar instead of on the ends. That's how we know it's a midpoint, not a boundary. And so this midpoint represents that first class of 155 to 190 versus these class boundaries representing the class of 155 to 190. They're the same class, just using a different way to delineate which group it is. Okay? Same information, same trends can be seen. Okay? Tomorrow what we'll do is we'll go over the other types of graphs. They're very, very similar and go off of the histogram. So we just actually have to make small changes to our histogram to get our frequency polygon and a few other things as well.